Please let me know if you can see my presentation.
Yes.
Okay. So once again, thank you very much for inviting me to give the speech during this special day for women. And I would like to present a result of my research, which are connected with morphodynamic of the southern Baltic Sea coast, and include together natural processes and anthropogenic impact. So, okay. When we are talking about the Baltic Sea, we go to the north of the Europe, and we have to go not only geographically to the north, but also we have to go back in time because the past of these areas influence very much to the previous and modern days. So when we are look for the map of the last glacial cycle for the Baltic Sea, we see that whole this area, whole the present Baltic Sea and almost whole the Poland at that time was covered by ice sheet. And this phenomena influence our coast strongly. So what we see on the Baltic coast today, you can distinguish very easily from that map that this is a sea which facing different problems in different places. For example, for the northern part, we observe land uplift. And what is red on the map, this is uplifting areas, but we are focused on the southern part of the Baltic, of the southern coast, and here we see the blue color. And this blue color is strongly connected with transgression of the sea. So it means that that coast is strongly affected by a sea level rise and with a strong erosion. So when we are talking about the Baltic Sea, this is a not too big, semi-enclosed marginal seas. We have to take into account the past geological settings, and also we have to include the glacio-isostatic adjustment, take into account eustatic water level component and others like gravitational and also meteorological and oceanographic fluctuation. So all this we should take into account when we are talking about the coastal change, when we are plan to predict the future coastal change, and when we, especially when we focus to the past, because if you want to predict the future, we have to look first to the past to distinguish what's going on and which process has a bigger influence to the coast. So we will talk about the southern Baltic Sea, mainly the Polish coast, and from that map we see that this coast today, because of the geological settings, is strongly influenced by risk of flooding and risk of coastal erosion. So that coastal changes are very important, especially when we are talking about Poland, but also when we are talking about the Europe, when almost 20% of the population living in the coastal zone. We will focus today on the section of 80 kilometers long of the western Polish coast. So here is a border with the Germany, Polish-German border, and 80 kilometers of the coast. From the picture, you can see that there is a two section of the cliff coast built from the till Pleistocene material. Some part of that cliff is built also from sand, and between there are barrier coast, sandy dune Holocene coast. As I said before, the Baltic Sea is semi-enclosed, tideless, wave-dominated, and this section of the coast is exposed mainly to the west, north, and northeast winds and waves. Along the coast, there are located some small municipalities, mainly touristic, and because of that, because to protect their infrastructure, some sections are also heavily protected by hydroengineering structures. When we look at the coast, the sandy coast has a very wide beach with a strip of the dune behind, and there are two different kinds of the cliff. The western part of the cliff coast is built mainly from till and sand, and the high cliffs, the highest on the Baltic coast, is mainly 90-meter height. The second section of the cliff coast is much lower, is about 20-meter height, and is mainly built from till. As I said before, the Baltic cliffs, the Baltic coast built from the soft sediments are very prone to erosion. And during the storm surge, this erosion can be very, very strong, as you see from that picture. But not only the storm surge caused the erosion on that coast. Sometimes even heavy precipitation can start the cliff retreat and landslides. My research based mainly on the aerial photographs, historical aerial photographs, and I indicate on each series of the aerial picture the dune baseline position to calculate the changes. So I analyzed how the coastline, the dune, meaning dune baseline position, changing during the time. And from that measurement, I calculate the coastline changes. So this is the graph which shows us for this whole 80 kilometers long section, the size of the accretion, and red is erosion during time span. And we can see that from that southern Baltic coast, there is a very big variation in erosion rate size and also in the spatial distribution of the accretion and erosional sections. We see that from the biggest changes occur at the first time period, and then the erosion and accretion rates decrease. But we see also during the time that the erosion is much more affected much longer section along the coast than before. We can distinguish some part of the coast with the small coastal changes. It's connected mainly with cliff coast, and with the highest rate of the coastal changes, which are connected with the river mouths. We also can see from this research that there are only few short section which has a homogeneous coastal development tendency along the time. Only 3 sections for the accumulation tendency, and 5 for erosional tendency. It means that for every analyzed time period, in this place occur the same process. But about 80% of this section, we observe oscillating tendency. It means in one time period we observe accretion, in another erosion. It means that the prediction how the coast will develop in the future become very hard and uncertain in this case. To avoid coastal erosion, there are many hydrotechnical construction and protection measures applied on this coast. Starting from the soft method, we observe beach nourishment. There are many groins, different type of groins, single and double T-shaped groins, double groins with the concrete inside. There are also many different types of the revetments and seawalls, starting from the light to the really strong and heavy construction. The length of the protected section is totally about 17 kilometers because they are together on the same section. They protect together the same section of the coast. It means that about 20% of this area is protected. Other 80 is still natural. But when we want to check how this protection measure influence the natural processes, we go into detail through the time. So we analyze the history of the coastal protection along the time, from the first jetty, which were built to protect the river mouths, and the next one, which extend the length of the coastal protection and also show us how the different type of coastal protection was used along the time. For example, the revetments in 50s and 60s, the hard protection in 80s, and now, fortunately, the soft method, beach nourishment. When we look into detail for the section location of the hydrotechnical structure, the black one is a hard protection, this strip is a groins. We see that the coastal changes, the red is erosion, the yellow accretion, and the stable coast, they are connected with that coastal protection. We see huge erosion bay at the end of the groin system. We see erosion bay at the vicinity of the jetty. And for the next time span, when the new protection method appear, we see that the coast react. There is a smaller coastal erosion bay, the smaller erosion near the jetty, but we see also that the erosion don't disappear and extend to the next coastal section. We see also positive influence of the soft method applied in the last time period. It means beach nourishment, which significantly improve the coast and increase the accretion rate. Sorry. I'm sorry, I go to another side. So when we look, when we go along the beach, we see the result of the coastal protection systems very easily. On the picture, we see the erosion bay at the end of the groin system. we see disappearing of the beach in front of the hard seawall. Sometimes it is completely, not only lowering, but completely disappearing beach, which is not very I'm sorry, but the tourists don't like such things. And also another negative effect of the coastal protection, it is extension of protected sections of the coast. So it means that from year to the next year, we observe longer and longer coastal protection systems. Sometimes in the future, we can have whole coast protected in this case. So go deeper into detailed analysis. I try to check what is the difference and which factor influence the most the coastal changes during that time. For this research, what is important, I use the section which is homogeneous from the geological and geomorphological point of view, and I check how the coast influence according to the dune baseline, beach width of the beach, and width of the underwater longshore bar zone. Because for the safe coast, the wide and high beach and also the sandy material in underwater zone is the best protection. So I check how they change along the time and how they change in space during that analysis time span. And I found that the rate of the changes is different in different time span, the highest in the first and last and the lowest in the middle. And I try to find some correlation between the dune baseline, weight of the beach, and weight of the underwater bar zone according to the coastline orientation, beach width, and beach slope. And I found some, but only for the first and the last period when the rate of the change are the highest. So the next step was to try to find the reason of that different changes during the time span. So the one of the reason can be the sea level changes, because when we look at the diagram of the sea level changes, we see that the sea level changes rise is different through the time, and when it's high, then also we observe the highest coastal changes on the coast. Another factor, of course, very important, are waves. And when we look for the data for the specific time span, we can say that there is no change. That when we look at the whole wave spectrum, it looks similar. But when we analyze the special waves height, significant wave height in the specific time span, then we see the difference. And maybe this is the reason of such a diversification. Also, the number of storm surge is important factor, but there is no linear relation between the number and the coastal erosion size. The much more important than the number of the storms in such period is the much more important, it seems to be the time between the storms. So when we observe the serious storms, they are much more affected the coast and cause a much higher erosion.
Sorry, Joanna, you should conclude.
Yeah, this is the last, almost the last slide. I only want to show also the diversification of the coastal erosion from the from the laser scanning data and show that on the same time we can measure on the coast huge accretion, huge erosion, and also accretion on the dune coast. That this is very important what we measure and which parameter we take into account. So conclusions are that these analyses show the considerable temporal and spatial viability of the coastal changes, even on the section which are geomorphologically and geologically uniform, that there is a influence of the coastal protection structure, and there is a greater erosion in the vicinity of the hydroengineering structure. And the most important, that for the reliable numerical modeling for the, for example, coastal prediction of the future, all these models should be built on the comprehensive understanding of the various factors and processes acting on different temporal and spatial scales. And that result pointed that there is a very high importance of the appropriate selection, representative sites used to forecast, and also the representative time spent for the analysis. And thank you very much for the attention.
Thank you. Thank you, Joanna. Are there any questions?
May I have question?
Yes, sure.
Margarita. Thank you. Thank you, Anna, for this really interesting presentation. It's very similar to what we have done in our study. So I saw that most of photos that you are shown in the presentation, the public and private properties, touristic infrastructure is built without required setbacks in the most erosion zones. So my question is how, in what way this is regulated? Because in Bulgaria we have a law, but actually this law is only on the paper, and how it is regulated in Poland, I'm just curious to understand. Thank you.
Thank you, Margarita, for your question. In Poland, we've got probably similar situation, because also we have the law that people, maritime office, they knows that they shouldn't allow people to build the infrastructure close on directly on the dune or cliff top close to the sea. But there are sometimes new buildings just on the top of the cliff, and now we observe how they build a very large hotel 100 meters from the coast. So we've got such a law, but probably similar like in Bulgaria, this is only on the paper and people don't care. Maybe they don't know, maybe we should share our knowledge, or maybe they want to, I don't know how to say what they want. Just earn money as fast as they can and don't care about the cost and the future.
Thank you. Thank you very much. And my best regards to Professor Formanchuk.
Thank you very much. I give him.
Thank you. Thank you again.
Okay, thank you. This was the last presentation from this section.
May I do a question, Victoria?
Yes, sure.
Very, very quick question. Thank you for the presentation, Joanna. And it's just a curiosity about the first slide that you show. You present a map where the zone at risk of erosion and flooding area were highlighted, were mapped. And just to know how did you map that area? It's from literature review or from other regional studies?
Can you talk again? Which map you are asking?
It was the first, I think, the first slide that you show in your presentation, and it was like a regional. The second.
This one.
No, the next one.
This
the first
one.
where you. The next. here.
This one?
There was a map which you highlight the zone, erosion and flooding hazard zone. Maybe the previous.
This one.
Sorry, this one. Yes. How do you map this area? It's from.
This map is from the governmental agency, and this was calculated or mapped on a base of laser scanning data. So our government provide the laser scanning of the whole country. And on a base of digital elevation model, they do some mainly statistic flooding, or for some areas, mainly for the river, they provide the more.
So also the rivers are included.
There is a mainly methodology for the river, but very less for the coastal zone treatment. So this coastal zone are not exactly mapped. Maybe I can say properly. Maybe should be better model with the high developed methodology. This is very simplified methodology for the coastal zone, but this high methodology for the rivers.
For the river. Okay, thank you.